All right, so we'll go ahead and get started. So hello and welcome everybody. Thank you for registering for the Endless Form seminar series hosted by the Cambridge University Biological Anthropology Society. We're an independent student-led society dedicated to origins research. We offer a warm welcome to our guest speaker today, Professor Bernard Wood. Dr. Wood is the director for the Center for the Advanced Study of Human Paleobiology at George Washington University, where he's the University Professor of Human Origins. Dr. Wood is a medically trained paleoanthropologist who, while studying at the University of London, was invited to Kubi Flora by Richard Leakey. Working with Michael Day, Philip Tobias, Alan Walker, and other researchers, Dr. Wood has contributed significantly to our understanding of hominin systematics and human origins. I'll now hand the time over to Dr. Wood, and we kindly ask that all questions and comments be saved for the Q&A session at the end.
Hi, well, it's very nice to meet all of you. Some of you I can see, some of you are listed, but to everybody I don't know, hello, and to everybody I do know, hello. Thank you for your invitation. This is the second of a pair of papers by myself and Richard Smith. And I will just introduce you to Richard Smith, and here is a picture which was taken in 1982 at a meeting which resulted in this book, Food Acquisition and Processing in Primates, which was edited by Alan Billsborough and David Chivers and myself. If you go along the top row, about just over halfway, you will see Terry Harrison, and there's me next to Terry Harrison, but that's not the point. Richard Smith is the guy here, and he was at the meeting, and he and I have been colleagues for a long time. Well, we haven't been colleagues in a sense, but we have been sort of we have been intellectual colleagues. We have never worked at the same institution. And this is the second of two papers. The first one was about sort of epistemology, about what sort of questions you can actually answer in relation to human evolution. And this one expands on a contribution I made to a review. The lead author was Tyler Faith, and the other authors are colleagues of mine or ex-graduate students in our program, and graduate students of ex-graduate students. And the point of this paper is for us to take a realistic look at what the human fossil record actually can tell us, or what it consists of. And therefore, if we understand what it consists of, or what it doesn't tell us, then we might be able to use it a little more sensibly and profitably. And the first thing, if you read the paper, and I don't blame you if you didn't, the first thing was that what we did was to make some sort of assumptions, and the working assumptions are that modern humans are most closely related to chimpanzees and bonobos, and that their common ancestor existed in Africa around 6 or 7 million years ago. So that's the working assumption. And the working assumption is that unless hominins for some reason left Africa, there should be a fossil record of the hominin clade somewhere in Africa for 7 million years after that most recent common ancestor. So those are the working assumptions. The thought experiment is the following, and the thought experiment is really an attempt to come up with a come up with a scenario which we can compare the existing fossil record to. And the scenario is the following: that each species, well, and the other part of the working assumption is that therefore, if there is a most recent common ancestor of modern humans and chimpanzees and bonobos, the assumption is that that common ancestor lived in Africa. And the assumption is that at the minimum, in order to get from that common ancestor to modern humans, you must have a sequence of ancestors and descendants that connects you. In other words, if you're 7 million years ago, that sequence will take you to the present. And if you're at the present, that sequence will take you back to the hypothetical common ancestor. So those are the working assumptions. The thought experiment, and the other working assumption is that at the minimum, there has to be that ancestor descendant sequence. In theory, there doesn't have to be any other hominin in the fossil record. In other words, at the minimum, you need just one chain to take you back to the common ancestor. So what is the thought experiment? Well, the thought experiment is that each species that existed in a hominin clade would be represented in the fossil record. And what I'm telling you today is not rocket science, and it's been thought of a lot by other paleontologists, but not really by paleoanthropologists. Paleoanthropologists, and I include myself, are not the most introspective of people. And so therefore, they tend not to look around them and see, well, paleoanthropology is a branch of paleontology. Let's see what other paleontologists are doing. Paleoanthropologists have a tendency to have tunnel vision, or at least partial tunnel vision, and I include myself in that. And this is an attempt to, in a sense, get away from that. I'm not sure how successful it is. You can be the judge of that. The second part of the thought experiment is that the fossil evidence of each species would be an unbiased reflection of its hard tissue morphology, and hopefully it would tell us about each of the major regions of the body. The other part of the thought experiment is that evidence of each species would appear in the fossil record soon after that species originated and would disappear just before that species extinction. The next part of the thought experiment is that each species would be sampled across its geographic range. Now, we don't know what the geographic range of the early hominins that we recognize and you have been taught about, but I'm going to assume in this thought experiment that the fossil record captures the geographic range of each of these species. And I'm also going to assume in the thought experiment that the fossil samples, would capture any temporal or spatial trends in intraspecific variation. So how far does the existing fossil record differ from my thought experiment? Well, let me sort of come clean, is that I think it would be sensible if we conceded that it probably differs quite considerably. Whereas I think there are some people who think that the existing fossil record is much the same as my thought experiment. I think that there is a considerable difference between the existing fossil record and my thought experiment. And so even if we were able to recover all the hominin fossils that have ever been preserved, because sort of clearly every hominin doesn't die in a place which is conducive to fossilization. And paleontologists call this the potential fossil record. My sense is the actual fossil record is many orders of magnitude less complete. And so therefore, it's probably less informative about taxic diversity, geographical range, and temporal span. And hominins come with an extra problem that they're particularly rare on the landscape. And if you look at hominin sites, there are very different strategies for collecting fossils. But the site where the strategy for collecting fossils is most likely to give you a reasonably reliable sense about how rare hominins or common hominins were on the landscape is probably the Omo-Shungura Formation. And if you look at that record, hominins are about 1% of the mammalian fossil record. So hominins would have been, certainly when I first went to Kubiforo, where the area was just chock full of game, there were herds of zebra, herds of elephants, herds of giraffe, and so on. Hominins would have been about as common as cheetahs were in that scenario. And cheetahs are not very common on the landscape. So what about the existing fossil record? Well, this is a sort of a woodogram of the existing fossil record, and each column is a hypothesis about the existence of a taxon or a collection of fossils from a site which has not been given a formal taxonomic name. The heights of the columns reflect the distance between the first appearance date, in other words, the earliest appearance of a taxon in the fossil record, and its last appearance date. So this is a particularly specious interpretation of the hominin fossil record. There are people who would interpret the hominin fossil record as consisting of many fewer taxa than this. So if we use that, and we'll use that just for the sake of argument, as that is what the existing hominin fossil record looks like. We ask the question, how many taxa should there be? Leaving aside whether you have a tendency to split and therefore to recognize more taxa, or you have a tendency to lump and would recognize fewer inclusive taxa. Leaving aside those proclivities, how many taxa should be recognized in the hominin fossil record? Now, there are reasons, I think, why there should be fewer taxa recognized in the hominin fossil record. And let me just show you a cartoon, and I apologize. I'm not very good at this sort of thing, and so this is a pretty hokey diagram. On the left, in the vertical axis is time, and on the horizontal axis is space. And so here we have a taxon. Its characteristics are gray circles. Okay. Some of the circles are smaller, some of the circles are larger, some of the circles are lighter, some of the circles are darker. And the point is that this is meant to reflect the fact that across 1 million years, which is the average length of a mammalian taxon in the Pleistocene fossil record of Africa, across 1 million years and across whatever its range was, it could be 1,000 miles or whatever it is. So just imagine on the left is 1 million years and on the horizontal axis is 1,000 miles. It's the same species, but it doesn't look exactly the same across its range or at different points in time. Sometimes it's smaller, sometimes it's larger, depending on changes in climate, and so on and so forth. But the thought experiment is that that's a single taxon. Somebody comes along and they find a fossil site, and they find a sample of this taxon, a subsample of this taxon. It's a temporal subsample and it's a spatial subsample. And that is large gray circles. And they write a paper in Nature or Science, and they say, we found large gray circles. Somebody else comes along, a different site, earlier in time, much the same region, but slightly different region, and they still find large gray circles, and they don't get their paper in Nature because they haven't found a new species, but they publish this in the Journal of Human Evolution. Somebody else comes along, they find a site in a different region, they find large gray circles, which we know belong to the same species, and they publish their paper in the Journal of Human Evolution. Somebody else comes along and they have a slightly different site sample because they have a mix of large gray circles and small gray circles. And they compare the measurements of the teeth, or the measurements of the postcranial bones, or the measurements of the mandible, with the measurements from the site samples from sites A, B, and C, and they throw their arms in the air. Boy, we've got something different because our fossils are outside the range of variation of the existing site samples. But you and I know it's the same species. But the editors of Nature don't know that, so they accept the paper for publication. So you and I know it's the same species, but just going to get rid of, you and I, it's the same species, but the people who find the fossils say, no, it's not the same species. And they, you and I know that it's I'm sorry, the people who find the fossils say, yeah, it's a new species, it's got a new range, and it's got a new FAD and LAD. But you and I know it's the same species. And so that is a reason why the existing fossil record might be more speciose than it actually is, because people have a tendency to say, I found a new site, I found a new site sample, it differs from the existing site samples, therefore it's a new species. Well, of course, that's not the case. Sometimes that's the case, but in this particular example, it's not the case. So why might there be more species than are represented in the existing fossil record? Well, there are a whole bunch of reasons why, but one of them was worked on, was written about by Simon Maxwell and Philip Hopley, and they wrote an interesting paper talking about something that other paleontologists have been talking about for years, which is rock availability. In other words, how at each stage in time, how much of the sediments that contain the fossils are exposed in a way that would allow those fossils to be recovered. And rock availability is a function of erosion. It's a function of a whole bunch of things. And rock availability is highly correlated with collection effort, because clearly you don't make an effort to go and look for fossils if there are no sediments of that particular time period available in that particular area. And so rock availability and collection effort are a reason why, although it looks as if some periods there are more fossil hominins than there are at others. The periods when there seem to be fewer fossil hominins may be times when there is not as much rock available to look for fossils, and therefore not as much effort has been made to look for fossils. And so those are just two of a bunch of reasons why the existing fossil record may not reflect the taxic diversity in the hominin clade. The next thing I just want to spend a couple of minutes talking about is spatial distribution. And if you plot where hominins are found in Africa, it's basically in there are sort of two windows that are provided in Africa. One is the window which is provided by the East African Rift system and the sites that are either in the rift or around the rift. The other window is an even smaller window, which is the cave sites in the Dolomitic uplands of Southern Africa. And there are a few early hominin fossil sites not in those two regions. One is in Chad, and there are a group of localities in Chad. Now, there are other places where hominins have been found in Africa and Northern Africa, but not early hominins. So if you add all these places together, the area where there is rock availability that people have committed collection effort and therefore have found hominins probably represents between 2 and 3% of the land surface of Africa. Now, and these places are like lampposts, you know. They are, you can imagine Africa being this huge parking lot, okay. Africa is a big continent, 3 times the size of the United States. It's a big continent. But you can imagine Africa as this huge parking lot. And in this huge parking lot, there are 2 lampposts, okay, where you can see underneath the lamppost. And these represent the areas where there are fossil sites. And this person comes back from the city, worse for wear, having been to a dinner, and she or he gets their keys out as they come from the train, and somewhere between getting their keys out as they got from the train and getting to their car, they drop their keys. Okay. Now, where do they look for them? Well, they look for them under the lampposts. It's the only place you can see. Otherwise, you're going to have to crawl around on your hands and knees, trying to see if you can feel your keys because you can't see. So these 2 regions are a little like, you know, the lampposts under which the drunk looks for their keys. It's the only place you can look. But does that mean that's where the keys are? Probably not. And does that mean that all significant events in hominin evolution either were played out in these 2 regions or were captured by evidence from those 2 regions? And I think that is just a crazily unlikely scenario. So what about the time? And the thought experiment said that, you know, the hominins there would be a fossil record soon after they appeared, and the fossil record would end just before they became extinct. We know that is, we know that these columns, let me go back, we know that these columns are minima, okay. It's likely that hominins were around before the first appearance date, and it's likely that they were around after the last appearance date. There are various ways in which you can try and estimate the confidence intervals of the first and last appearance dates. and they depend on, for example, are there any fossil sites where there are no hominins that predate the first appearance date of, say, Australopithecus afarensis? And you then have to say, well, what does no hominins mean? Well, no hominins means probably that you have to find several hundred bovine fossils or several hundred pig fossils before you can begin to think that there were no hominins. Because hominins are so uncommon, just finding a few mammalian fossils but not finding hominins does not mean that hominins were not there. And so hominins are a really, a good case of absence of evidence is not evidence of absence. And then there is the challenge of reproducibility. And the thing is, and I've done this myself, and so nearly all my comments are as directed against me as they are as anybody else. The question is, what methodology do you use to interrogate your fossil record to work out whether you think there is the evidence to recognize a new taxon? And the answer is, you obviously can only use the evidence that you have. In other words, if you only have teeth and jaws, then you have to do it on the basis of teeth and jaws. But if you, and the evidence that you have may not be the evidence you would like, because it may not include areas that are likely to be sensitive to taxonomic distinctiveness. And the other thing is that there are confirmation biases going on the whole time. There are sort of there are cognitive biases. I'm sorry, of which confirmation bias is one. And although as individuals we say, well, I'm not biased, I go about this, I have no preconceptions. That's just not true, apparently. I mean, as much as we would like to think, it's just not true. And so when you add all these problems to how we should view the existing fossil record, my sense is that that we probably, the existing fossil record gives us a very limited sense of what the actual fossil record was. For various reasons, the locations of those columns are all likely to be taller than they actually are. And this means that if any of those columns line up on the existing fossil record, it's a fool's errand to try and sort of chase some explanation, because those columns are not when taxa evolved or when they became extinct. They are minima. And so, if you try and sort of chase some sort of climatic explanation for something that happened at 1.8 million years ago, it probably didn't happen at 1.8 million years ago. It happened before 1.8 million years ago, or it happened after 1.8 million years ago. My sense is that unless you think that hominins were confined to the East African Rift Valley and to the area, the Dolomite in Southern Africa, that we have a very poor sense of what the geographic range of hominin species was. And because hominins are so rare, it's likely that there are several, if not many, hominin species that have yet to be identified. And fossilization will occur in some paleoenvironmental conditions and not others, and therefore this is another reason why the existing fossil record is likely to be misleading. But it's pretty evident that some of my colleagues think that the taxonomic hypotheses captured by the figure are close enough to the actual taxonomic inventory of the hominin clade to merit generating comprehensive higher order narratives about human evolutionary history. But the problem is that if you come up with complex explanations for an incomplete data set, they're almost bound to be wrong. And although we each of us have an urge to do this, we need, even if we can't resist the urge, we need, when we are giving into the urge, we need to have a little person sort of sitting on our shoulder just saying, just want to tell you that this might be a fool's errand. So we're emphatically not suggesting that, you know, that all is lost and there's no point in looking for hominin fossils. That's ridiculous. But we are suggesting that the fossil record should be seen for what it is, which is an incomplete record of human evolutionary history that limits what should be said about it. Comprehensive explanations based on incomplete data are likely to be wrong. And by all means, go ahead and generate narratives, but the narratives should be sort of treated as heuristic devices, not as accurate and comprehensive descriptions of past events. And the other thing is, you know, I mean, I've been wrong so many times that you know, I've had to get used to it. I would urge people, even if you think that this paper and this presentation is you know, might contain some hyperbole, I would urge you to at least give some thought to what I've said, because if you don't, I think you're going to waste your time coming up with explanations for things that actually don't exist. So thank you for allowing me to talk that long. My screen is now blank, but I'm assuming that I can do something about that. Let me escape. Okay. Oh, the last one, David Pilbeam sent me this quote from Cromwell. "I beseech you in the bowels of Christ, think it possible that you may be mistaken." That's my parting message.
Thank you, Professor Wood, for this presentation. And we'll now go ahead and open it up to a Q&A session where you can either raise your hand or submit a question to Dylan or I, and we'll read it out for you.
If you like, Bernard, I'll start off. How are you? Nice to see you. But can I say that wasn't the most cheerful talk on human evolution I've ever heard. And particularly as we had Lee last week, who is Tigger to your Eeyore, I think. I mean, I take your point, and we have to be very cautious. And I'm probably one of the people you had in mind when you talk about trying to sort of build models and things of grand nature. But I take your point. Okay, let's keep away from macroevolutionary questions. But then what if you were to advise students starting out? What questions should they be asking you? You think you can get secure answers, because you're suggesting we can't get them on the macroevolutionary patterns, but there must be a core area where you think, okay, this is a more reasonable set of questions to approach.
Well, I think, trying to work on how many taxa, would be a very sensible thing to pursue. But it would be so how do we go about working out whether a collection of hominin fossils is so variable that it is highly unlikely to sample just a single taxon? The problem is, that our extant models are either modern humans or they are closely related higher primates, which lack the distinction of hominins, which is having small canines, which, I'm not saying that every higher primate with small canines is a hominin, but I am saying to be a hominin, you probably have to have small canines. So we don't have a comparative model. And the comparative models, even if we accept that sort of chimpanzees and bonobos are a good comparative model, most collections of chimpanzees and bonobos in museums at the most, the most span 100 or 150 years of time. And they come from a single location, or, if not single locations, they come from the same region. So how do we translate that into a yardstick for making judgments about taxonomic heterogeneity? And that is something that I've been thinking about for the whole of my career, and I have not come up with a satisfactory solution. And I'm just hoping that a bunch of smart people will come along with a satisfactory solution. But I mean, I'm not sure what it is. So I think there are lots of interesting, things to ask. What were these creatures doing? How were they moving around? What was their posture? What were they eating? All those are reasonably tractable questions. But, why did hominins become bipedal is a really attractive question, but it's not a question that I think you can answer scientifically. In the absence of a time machine, I don't think you can answer it scientifically. So I think, the answer is try and tackle questions that can be answered scientifically and try and stay away from questions that mean that you have to stray away from science in order to answer them.
So, I mean, just to follow up, in a way, you're saying paleoanthropology should get back to its functional morphology roots.
Well, I'm saying paleoanthropology should function like other branches of, paleontology, which tend not to answer, which tend not to ask why questions.
I will think about that one. Thank you. I'm not sure I agree with that, but anyway, thank you very much, Bernard. I think there's a question that Dylan Flicker wants to ask us. So probably just.
Yep. So sorry, it seems like Jared's mic wasn't quite working there if he was calling on me, but I do have a question, which is related to why you prefer a specious taxonomy, as was displayed during the talk. You mentioned that the reason for preferring to interpret the fossil record with more interspecies variation would be because of the sampling method across space and time with which paleoanthropologists must recover fossils, and that the reason for preferring a specious taxonomy would be that we don't really know the full diversity of taxa in the past because we haven't recovered all taxa because of rock availability and collection effort. It seems like the reason to prefer more interspecific variation would be based on the observance of what we have currently recovered, whereas we wouldn't prefer a specious version of the fossil record based on what we currently have recovered. Did I get that correct?
Well, I'm not sure I completely followed the question, but let me explain to you why I prefer specious interpretations. It's because it's much easier to put two species together than it is to split an inclusive species apart. And so it wouldn't take you 5 minutes to convert a specious interpretation by saying by saying this is a junior synonym of this, but it would take you much longer to take a lumping version and try and convert it into a more specious interpretation. So one of my preferences for at least recognizing on a diagram a larger number of species is because it's much easier to lump them all together, to lump them together and make fewer inclusive species while continuing to follow the rules of the International Code of Zoological Nomenclature. And as boring as those rules are, unless we have a set of rules, we end up with, what we had recently. Oh, well, we don't understand Homo heidelbergensis, so let's just give these things some new names. Well, the problem with that is that it flouts rules. And once you flout rules, then where do you stop? So that's my reason for thinking, in sort of species terms. I really don't know, it depends whether hominins were like carnivores, in other words, they were pretty cosmopolitan, or whether hominins were endemic to geographically restricted regions like lake basins or something like that. I don't know. So I don't have you'd have to talk to my therapist to work out why I'm inclined to favor a more specious interpretation, but I just am for the reasons that I outlined, because it's much easier to change it.
Thank you, Bernard. I enjoyed the talk and I enjoyed the questions. Can I follow up on Dylan's? I agree entirely. I think that specious solutions give us analytical power in a way that if you lump everything in one, you cannot get at trying to untangle and understand. And but then what do you do? So following your advice in the talk, so what do you do that people say, okay, so let's play with the idea that there's a unit called Homo bodoensis, for example, in the Middle Pleistocene. They don't like rhodesiensis, or call it rhodesiensis and helmii and heidelbergensis. So where do you stop with your narrative saying, I don't mean this to be a species necessarily. I mean this to be a hypothetical taxon that allows me to explore if this diversity actually makes sense, if these patterns have correlates or not. So what would you do? Would you not give it a species name? Would you go like Chris, you're there? I can see Chris there. Would you go like Chris and say, oh, we have to talk about derived Homo sapiens and so on? So what do we do? Do we qualify semantics in vernacular language, or do we give it species names? And Chris, I'd like to hear you as well. Okay.
My sense is the following, I am not a smart person. My sense is the following. We know species exist. We struggle to identify them when we have behavioral evidence, when we have morphological evidence, when we have genetic evidence. So we struggle to identify modern species, even though we have orders of magnitude more information than we do about hominins 2 million years ago. So we know species exist. We know they can be identified. We know that they are discrete in a sort of qualified sense. And so therefore, 2 million years ago, we assumed that species existed
as well.
They were discrete in the same way. And so my sense is that you can use formal nomenclature to identify. You'd have to be sort of crazy to think that OH7 was the same species as OH5. even though they had no morphology in common.
Yeah,
One was
yeah,
the cranium,
absolutely.
one was
Yeah.
the mandible, but you just look at it and say, will I ever live, if I live 1,000,000 years, will I ever see a chimpanzee that has that cranium and that mandible? And the answer is no.
No.
So there is a sort of, reductio ad absurdum, sort of sense to this. But my sense is that, there's no harm in recognizing species. But, when you come to things like, what's going on at Dmanisi, what's going on at the Cima de los Huesos, I don't know. Let's, for the time being, let's just sort of talk about them as site samples. And then if somebody comes up with a persuasive argument, we can add those site samples to the hyperdyme of an existing taxon, or we can recognize a new taxon.
Thank you. I can see that Chris says that his microphone is not working, so he's listening only.
Yeah, I guess I just have a follow-up to that, which is there seems to be almost a reluctance to use subspecies as a form of classification in the hominin record. And I was wondering what your opinions on that are as like kind of a middle ground where we can address the degree of variation that we see while also maintaining a degree of lumping. You are convincing me to be more of a splitter, by the way.
I think the problem with sort of subspecies is that it's an even more complicated problem than recognizing species. And I don't want to give my uncertainty or my inability to, to come to a conclusion. I don't want to make it sound as if it's more official and smarter than it actually is by giving it a subspecific name. I'm not a zoologist, and so, my sense is that subspecies are used pretty sparingly. And I don't think we should adopt them as a sort of, a cop-out.
I think that's such a valid point, Dylan. So if you think that subspecies, which is a construct that we do to explain just shifting patterns of variation, it's overlapping variation, but with shifting levels of overlap. And, in paleontological species, we just do not have a handle on that variation. That's population level variation. That's what subspecies is describing. And I think we don't have populations to do it. So I think subspecies is a rush thing to do.
And do we have any more questions from any of the guests? You're also open to send them to Dylan or I, and we'll read them out as well. But we've got a good discussion going.
Well, I'm sorry to be such an Eeyore, as Rob suggests. It's not that I mean to be an Eeyore, but it's like an actor on a stage. Unless you go on the stage and exaggerate, the people are not going to hear you. Okay. If you just sort of go on the stage and talk as you would sort of talk to a neighbor. So in order to make my point, I'm clearly exaggerating. But I want to exaggerate, but the reason I'm exaggerating is that I want you to think about this. And you can think about it and then say, Eeyore, go away, Lee, come in, and that's fine. But I don't want you to make that decision without actually thinking about what it means.
Let me just add, Bernard, that of course, Winnie the Pooh, you need both Eeyore and Tigger. I mean, the books don't work without both. It doesn't
work with one or the other. Yeah.
I know, but I think, let me say, I fully agree with you about the specious nature of the hominin record, and it's obviously a clear it's the pattern we see, and it's the pattern I think we would expect. I have a slightly methodological question. So you're obviously arguing strongly for caution, and I think that's absolutely right. And there's a lot of exaggeration, but there's also a place for we can be a bit Popperian and say what about the bold hypotheses, which then take us into new territory, driving the subject along, and in a way, without those bold hypotheses, we might end up being a little bit stuck.
Yes, I mean, that's right. I know that there was a hand raised by Mark Collard, somebody to see. Yeah. I mean, I'm not against sort of bold hypotheses, but you must understand that I was educated as a doctor, okay? And, if you're in a hospital, nobody was interested in your bold hypothesis.
Absolutely. No one wants a bold surgeon.
They were interested in, whether you had evidence, and so on, and so I agree that the bold hypotheses are part of the Western warp of what we do, but I think they're only part. Mark.
Good morning or afternoon or whatever it is, wherever you are.
Hi, Mark.
Hello, everybody. I wanted to try and push you a bit on this avoiding why questions. You were pretty explicit there about trying to discourage people from thinking about why questions because they're difficult to answer. But I sort of understand the appeal of that position, but I'm not sure it's actually empirically valid. I mean, is it actually the case that why questions have proven to be more difficult in paleoanth than how questions? So if you look at, for example, the debate, long-standing debate about how the Australopithecines moved around, which is a how question, is it any more resolved than the why question of why bipedalism arose? I mean, I don't necessarily think there's an obvious difference between those two questions in terms of their degree of resolution or the degree of consensus about them. And on top of that, I think the why questions actually quite often have driven research in a very productive way that how questions quite often don't. So, for example, thinking about climate change as a driver of human evolution, that's obviously resulted in a huge amount of research, and it's a why question, and it's been very productive to think about the potential drivers of human evolution. The why questions are I think actually worth investing time in. So I just want to see whether I can provoke you to say a bit more about that.
Well, you can provoke me. It's nice to hear you. My sort of caution about why questions is largely directed at graduate students, because I think basing your thesis on a why question is a bit like beginning to learn to be a circus acrobat by going straight into the most into the highest part of the tent and that sort of thing. My sense is that why questions can be asked. I think, for example, why questions are a good way of generating research support because organizations like the NSF or research councils in the UK or in Canada, they like the why questions because it gives them something to tell the politicians. Oh, we're trying to find out why. Okay, and the politicians can understand the word why. So I've got nothing against why questions, but as a personal, but as questions to drive somebody's personal research agenda, then I think it's a bit risky. And I think to say that, well, you know, how questions are often as risky as why questions is not a reason to give people license to ask why questions ad libitum. Why questions are very interesting. You know, of course, you know, I would sort of desperately like to know, why did Paranthropus become extinct? Why did this and that sort of happen? But when I actually try and convert those informal questions into a scientific program, then I have difficulty doing that. I have to go back to how and to come up with, say, okay, you know, there are maybe four competing explanations. How can we try and eliminate the least likely? And my sense is that what I've been trying to do about human evolution is not to find out what happened during human evolution, but just to reduce our ignorance about human evolution and to try and eliminate the less likely things. But I don't think I'm going to alight on what happened, but I'm going to get closer to a short list of things that might have happened. I'm not sure that that's going to satisfy Mark.
That was a good answer, thank you.
And if we have no more questions, thank you, Professor Wood, and I'll go ahead and hand the time off to our Vice President Dylan for closing remarks.
Well, first of all, I want to say thank you to Professors Wood, Lahr, and Foley. I have been convinced to use species as a greater analytical tool. So thanks. Thank you so much, Professor Wood, for speaking to us. And we know that you actually spoke to our predecessor society in 2019 before it unfortunately was a victim of the COVID pandemic. So thank you for returning to speak to our resurrected version of the Biomath Society here at Cambridge. Just shameless plug, we do have another seminar at the same time next week. Vincent Fernandez speaking to us about synchrotron X-ray tomography in heritage studies. And I hope you guys all attend. So with that, we're going to go ahead and end the meeting. Thank you all for coming and for your questions.
Okay, very nice to see people, or at least to hear them, if I didn't see them.
Thank you, bye.
Thank you, bye-bye.
Thank you.
Thank you. Thanks very much.